In this video, we take a look at some sample course structures and think about and discuss ideas for how to put together an IBL course. So the general topic of this video could also be described as planning a course, or it could be described as building a syllabus. And I want to get across once again that in this video, we're going to look at some examples, but these are just meant as starting points. Each instructor has to come up with their own choices and solve their own problems. So these are starting points for sure. They're not prescriptions. They're not the only way to do it. And I hope what you get out of this is some ideas to think about and how you can adjust these parameters so that they fit your course and your students as best as possible. Okay, we're going to break things down into 3 parts to help you with the planning process. And what I like to do is to think about a typical day in my IBL class. So what does a typical day look like? And then I think about assessment. How am I going to assess my students? And of course, we think about materials, like what are the students going to work on and how am I going to assemble those materials and deliver them to the students? All right, let's take a look at the first example. So this is IBL Calculus. So we have a fixed textbook. It's a multi-section calculus, meaning that there are several instructors teaching the same calculus course. At my institution, we typically have about 35 students in each class. This is not a vital feature of this example. You could have more students, you could have fewer students, that's fine. The materials that we're going to use is we have a fixed textbook, so then we make IBL handouts for each section. And that's described in an earlier video in this series. And then the typical day that we'll use is to have an intro for about 10 minutes, also known as a mini lecture, then switch to using the handout and getting students engaged in learning the math for the day, and then an outro or a wrap-up for about 5 minutes where you go over the main ideas and then set like what is the next section, etc. So a typical wrap-up for the end of the day. So that would be what the typical day looks like. For calculus, I'm going to share a couple ways to assess students with the same typical day structure and the same course materials. So the first example is to use a more conventional way to assess your students. So 2 time tests, a homework component, a growth mindset component, and a final exam. So this is a assessment strategy that would be very familiar to students. It would not surprise anybody, I believe, except perhaps the growth mindset part, which you can leave at 10% or you can decrease it if you feel uncomfortable giving 10% of the grade to growth mindset assignments. Anyways, this is a starting point you can use things that you're familiar with if you've only given time tests before and just add in something like growth mindset assignments to start to change your assessment practices. One of the reasons why I'm sharing this example is because some instructors aren't able to freely choose what's on their syllabus. They have pretty tight requirements of what they have to have in terms of their assessment plans. So what I want to say is that you can still do IBL in that setting. It may not be ideal or it may not be what you want to do exactly, but you can still have a successful IBL class in that scenario. So I'm sharing this as an example. Also, another consideration could be that you may not be ready to do things like presentations or portfolios. And in that case, stick with what you know initially, and then you can grow into those other parts as you go along with your teaching. So you don't have to make all your changes all at once. You can take it, one step at a time. Another way to assess your students in an IBL calculus course is to use a mastery-based grading system, or it's also called a standards-based grading system. And I've heard other people call it spec grading or specifications grading. I believe these things are basically the same thing, although there may be some differences. And what I'm going to do is explain this through a couple of slides and some examples, because I think that'll work better than if I just go through and explain and talk over all the parts. It seems a little complicated at first, but actually once you get the idea, it's fairly straightforward. All right, so here's a diagram that helps explain how a mastery-based final or standards-based grading system works. So what you do is you assign students a pre-final exam grade, and that can be based on the usual things like tests, homework, quizzes, whatever else you want. And so they come into the final with a pre-final grade. And then the final exam is structured into two parts. So part one are the basic or fundamental things that students should learn. And typically we'll have, say, 10 questions. It's pass-fail. And students should know how to do all these problems, basically, except for small, say, minus sign errors or addition errors that they might make in the heat of the moment, while they're going through the exam. And then if they pass, then they get the maximum of their pre-final grade or C minus. Okay, so if they come in with a B and they pass, they get to keep their B. If they come in with a D and they pass part one, they get a C minus. All right. And then part two of the standards-based final or mastery-based final, it has all the challenging problems. So these are things like optimization, volumes, things that require students to have to think through, apply their knowledge, use good problem-solving skills, and use good communication skills. So these are problems where students can really demonstrate that they learn the material at a deeper level. And that's an opportunity for them to increase their grade to a higher grade than what they're coming in with. I think it'll really help if we look at some examples. So we'll look through a series of scenarios until you get the idea of how these things work. So let's take this student. So pre-final grade is a B. The student passes part one, but doesn't make progress on part two. So then the final course grade is a B. In this example, the student is going into the final exam with a D or an F. And the student passes the final exam part one and proves that the student understands the fundamentals for Calculus 1 and also doesn't make much progress on part two of the final. In this case, the student earns a C or a C minus in the course. In this example, we have a student who entered the final exam with a pre-final grade of a B, but did not pass the final exam part one and also did not make much progress on part two. So in this case, the student's grade went down. It went from B to a C for the final course grade. One of the common questions we get is, what happens if a student does not pass final exam part one? And a typical way that faculty handle this in IBL courses is to put in a statement or a clause in the syllabus where if a student does not pass part one of the final exam, then their grade can go down by up to a whole letter grade. So in this case, we saw a student going in with a B and then coming out with a C. Let's look at a happy example where a student goes in to the final exam with a B minus, passes final exam part one, does well on part two, and ends up with the final course grade of an A or an A minus. So this is an example where a student was able to demonstrate that they understood the calculus problems that they were working on and were able to apply in part two their calculus ideas to problems that they hadn't seen before. They may have seen problems similar to these, but they really had to be careful, be thoughtful, understand the questions, use good problem solving skills, have good algebra skills, etc. So they're displaying that they really got it. They really understood it and their knowledge was solid. You can't fake it on problems that you haven't seen before. So that's where part two, writing good problems for part two, is important. So in that case, you have good evidence that the student really learned it, really stepped it up, and really earned their A or A minus. All right, so let's change gears and look at some proof-based courses. So what we're looking at are courses like Intro to Proofs, Number Theory, Abstract Algebra, Real Analysis, courses like that. And these are courses where you'll have math majors predominantly or science majors, and these are students who are in their third or fourth year of college. The context is that you have more instructor freedom. So typically, if you're teaching number theory, there isn't another course right after that, or instructors are allowed to more freely choose what textbook or what materials they're using, as long as they achieve what the department sets out for that course. So you might have 35 students. Typically, upper division courses have fewer than 35 students. And then instead of having, say, a conventional textbook, you may have an IBL textbook, or maybe using IBL course materials that have been developed by other people or by yourself. A typical day, I think the theme would be that students are presenting and discussing proofs in groups and in the whole class. So that'd be sort of the main activity that happens in class. The instructor could also step in and give lectures or mini lectures at times, at important times, and then use activities like group activities for any remaining chunks of time to start a new topic or to wrap up a topic. So in this kind of situation where presentations are a vital part of the class, it makes sense to put 25% or 30% of the grade on the presentations. So in this example, I have roughly 1/3 of the grade is based on presentations, in-class tests, and the final exam, and 10% for homework. So this would be, once again, a more conventional approach, except that you're adding on presentations. I think this is a good step if this is your first time through a proof-based course. It's not to change everything all at once. Add the presentation component and work on grading those, and then you still have the other things that you're more familiar with, like tests and homework, etc. So in proof-based courses, you can take things in a lot of different directions. So in this case, I want to highlight portfolios. So you can add in portfolios into your courses and use that as an additional way to assess your students. And this is especially important in courses where you don't have a conventional textbook with all the proofs and all the theorems just spelled out for students in one source. So in a sense, you're having students write their own textbook and discover the proofs as a class together. So in that situation, it does make sense to have students compile a portfolio so they have a good record of what they learned in the course. Let's take a closer look at portfolios. So in a proof-based course, where the course does not have a conventional textbook, students need a record of all the proofs and solutions and strategies that are needed to solve the problems. So one of the responsibilities we want to give to students is that they have to be in charge of keeping track of what's happening in class. So one of the scenarios that you want to think about is a student may wonder, oh, how do I solve number 17? And if they didn't take good notes, then they won't have anything to refer to. They don't have a textbook to refer to. So instead of the textbook, they could have a portfolio. So the requirement of keeping records of what goes on in class helps keep students up to speed, keeps them with the class, and they also have the solutions and the proofs to refer to later on. Another way to use portfolios is to have productive failure assignments be part of the portfolio. Students can write about instances when they made a mistake and learned something from it. And so this is a place where you can make those kinds of assignments and make it part of their portfolio. So not only a portfolio of the work that they did and their classmates did, but also a portfolio of the mistakes that helped them learn the math better. A third reason to have portfolios is for reflective writing. So a good way to use reflective writing is at the end of a body of work. So at the end of a chapter, have students go back, look at the material, and highlight the main ideas and the main strategies and how all these theorems fit together and what they mean. So that could be a good way for students to do some review, but at a higher level than just redoing problems. I'm going to make a quick note that for proof-based courses, you can also use a mastery-based final exam option. It doesn't have to be a conventional final exam. So that's also on the table for you when you're designing your course. I want to talk about course materials now. So course materials as a topic is a very large topic. It's the same as saying, let's talk about course materials for the math major. It's a lot of material. It's a lot of different topics and subtopics. But what I will tell you is that you can go to our website at inquirybasedlearning.org and find links to places where you can start to look at IBL course materials that might be suitable for you. So that's an option. So please check that out. It can save you a lot of time and give you a heads up and help you provide the best possible experience for your students. Selecting course materials comes down to three main choices. The first choice is to use and adapt existing IBL materials, and this is a great choice if you're just starting using IBL. A second choice is to use IBL with the textbook that you're given. For example, if you're teaching calculus and your department assigns a textbook to all sections, and you decide to make handouts or adapt handouts for each section of the textbook that you're covering. A third choice is to create your own IBL materials. Let's talk about the pros and cons of these choices. If you're using and adapting existing materials, that's a great starting point if you're teaching a course for the first time or if you're new to IBL. Developing IBL course materials takes a lot of time, and when you're first starting out with IBL or if you're teaching a course for the first time, you may not have a lot of time to invest in developing materials from scratch. So a good recommendation is to use and adapt existing materials in that situation. One of the pros of using IBL with a textbook is that you already have a structure from a textbook that's given to you. And so you don't have to make a lot of choices about when to teach what and how to sequence things. And really what you're doing there is you're enhancing the learning experience by selecting really good quality math tasks and executing them well. So I'm going to highlight a couple advantages of option 3, creating your own course materials. One advantage is that when you create your own course materials, you really understand how these problems, or where they came from, how these problems work with your students, and how that affects the learning. So you can learn a lot about how problem posing really affects the learning that goes on in the classroom. Now, the downside, of course, is that writing up your own problems from scratch can take a lot of time and energy. And so you need to balance that with your other responsibilities and obligations at your job and with your personal life. One of the other advantages of using your own materials or creating your own materials is that if you teach a course multiple times over several years, then you can refine those course materials again and again. And you can really learn how students learn the mathematics and how they engage with the mathematics. So it can really sharpen your ability to ask good questions. So I think in the long run, it's a good investment in time. And so maybe the question is, when is a good time for you personally to get started on this process? And also picking a good course. So if there's a course that you know that you're going to be able to get repeatedly, say every fall you get to teach analysis, that might be a good place to invest your time and energies in developing your own course materials. If you're teaching history of math just one time because someone went on sabbatical and you may not be able to teach that course ever again for the next 10 years, maybe that's not the best place to invest a lot of energy, given that you won't be able to take advantage of that repeated prep, that repeated going through the materials and learning more about how you phrase the question affects the learning and how you can adapt your questioning techniques to help your students. All right, now it's time to recap what we've covered in this video. So the putting together a course or looking at sample course structures came down to 3 main parts. So one is to think about the typical day in your class. So how are you going to structure your day-to-day operations of your IBL course? The second thing to think about is assessment. So once you decide on what your course is about and how you're going to engage with your students with the mathematics, then you need to select how you're going to assess your students. And so these assessments are tied to your goals and how you set up your class and what you're going to emphasize. And once you've decided those things, then you can start looking at the course materials that will support your goals. So then if you're going to use a textbook and you're going to build handouts off of that, that's one choice. If you're doing a proof-based course and you're going to ask students to prove theorems, then you will have a different set of materials. Now, a little caveat here is that this is not a linear process. Typically you'll think about a typical day, and then you'll toss around ideas about assessment, and then you'll look at the course materials available, and you may not see something that you like, and so you have to kind of revisit, okay, maybe I can adjust a typical day in this other way, or maybe I need to think about assessments in another way, or maybe you'll start with course materials and see what's available and kind of adapt what kind of typical day you'll have, because you might be flexible in what you are willing to do. So this is not a linear, simple process. You might go through this in a variety of ways, but these are definitely 3 things that you'll want to think about when you're putting together your course. All right, so that's it for this video. Thanks for joining us. If you want to learn more or engage with the IBL community, come visit our website at www.inquirybasedlearning.org. Thank you. Bye-bye.